All right, we are on our last 5 problems of notes. These are just putting everything together with our theorems and being able to find the value of a missing variable. I want you to know that a lot of these are decimals and answers, but I believe your homework is not that terrible. It should be normally decent numbers. But it's the same setup. We've got to determine similarity between postulates, and we got to justify our answers, and then we have to look for the value of x. Also, we have to understand that all lengths in here are centimeters, so that means we have a value for these units and we need to write them as units. So looking at our first one, we have a small triangle inside of a larger triangle. We have 2 side lengths for the small one, a length and another length for the large one. We need to find x and we need to say what theorem justifies our answer. So real quick, we do notice that we have a length of 8 but a small length of 3. That means this large triangle is 8 plus 3, which means we have a total length of 11 here. So that should help out if you can't visualize that. Well, I have a side, and a side. That means I have to potentially find an angle looking at our 3 sides. But remember what I said about, hey, if this triangle and this bigger triangle share an angle, that means this angle is the same. But that doesn't help us with side, angle, side. Well, these arrows indicate parallel lines, meaning they'll never touch, meaning we have corresponding angles here. So if remember that 2 parallel lines that never touch, and you have a transversal that goes through them, so technically this is a transversal, we can see that the angles that would be created here has to be the exact same angle that is created here based off of our corresponding theorem from our past few units. So now we definitely have a side, angle, and a side. So by SAS, we've got this. Well, you can also see that our angle and angle would have been another thing. So we can say SAS or angle, angle. We just can't say side, side, side since there was not a third side. So there are multiple ways to state these theorems work. So we have 2 here. But now we need to find x. So to solve for x, we can see 8 and 10 correlate here. So I'm going to go smallest, which is 8. And it corresponds with our 11. Even though we don't know what x is, it's on the same side. So we say 8 and 11. And it has to equal our next one of 10 over x. Okay? So this again is just some proportions and we're putting them together. So we're going to multiply across and we're going to get 11 times 10 equal to 8 times x. And we're going to notice that 110 equals 8x. We're going to divide by 8. And x is going to equal 13.75, which, since we know this is in centimeters, it's in centimeters, okay? So sometimes you're just gonna have to plug and chug. You don't have to give me fractions, just plug and chug, give me the version with decimals. So we have just done number 1. All right, our next one. We are looking at 2 triangles that correspond, and there are 3 sides given for one triangle and 3 sides but a missing side of another. So that right there should indicate we might be looking at side, side, side. But there's also been given angles. So we have a 90 and a 90, and we also remember our vertical angle theorem. So right there, that means we could be looking at SAS or also our AA because we found 2 angles that are similar. So we're seeing all 3 similarities here, but we have to be able to solve for x. So we should assume that they are similar because we saw that they have enough information to be like, yes, we can do this. So now we're going to look for x. Well, I know that 12 and 36 are going to correlate because they share the same line. 10 and 30 have to correlate, and then x and 24. So the one we're looking for is x. So I'm going to use x over 24, definitely, since we need to know x. Well, I personally like 10 over 30 better than 12 over 36. You can use whatever you can see, but I'm going to use 10 over 30. And now all I have to do is solve for x. So I'm gonna take 24 times 10, and it's gonna equal 30 times x. 24 times 10 is 240, equal to 30x. I divide by 30. So we take 240, divide by 30, plug it in your calculator. Your zeros are gonna cancel, and 24 divided by 3 is 8. So this one actually was pretty. So we have x equaling 8 centimeters. If you feel comfortable enough, please go ahead and attempt 3, 4, and 5 and just follow along with me at the end. Okay. All right, I am gonna erase these so that we can have more room to see the last 3 problems of the notes. Almost there. So once again, we have 2 interlinked triangles. We can see right here that they have to share angle, angle here for our vertical angle theorem. And we have 2 sides. So this is SAS. We also have 2 parallels with a transversal that's cutting through them. So we can also see that corresponding is happening. So because of corresponding angles, these 2 are also the same, meaning this could also be angle, angle. The only thing it cannot be is side, 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 because we were not given a 3rd side. So these are our 2 theorems that we could say. We now need to solve for our x. These guys are on the same line, so 16 and 36.8 have to be similar to each other. And then x and 42.09. So this is x equals for 42.09. Again, don't be afraid of decimals. All you have to do is plug it in your calculator. So we're going to cross multiply, and we're going to see 16 times 42.09 has to equal 36.8 times x. Again, just plug it in your calculator. It's okay. So 16 times 42.09 is going to be 673.44 equal to 36.8x. And now all you have to do is divide that whole answer by 36.8. And you're going to get that x is equal to 18.3 centimeters. Please do not be afraid of decimals. Those are more accurate than real integers. So please be okay with them. Okay, so the next 2 have a trick to them, and these definitely need to be paid attention to. So right now we have 2 triangles. I'm going to go to 4 first before 6, but they're 2 triangles, one small inside of a large with 2 parallel lines again. So we're used to that. We can see from 4 that this angle they have to share. Well, we have a side, and an angle. So we have side, angle, side. And because of parallel, corresponding says that these 2 also have to be the same. So angle, angle. But now we have to determine x. Well, we have x and 12 for our small one, but our large one has not been found quite yet. So what we had to do for our large side is we have to add the 2 things here to be given to us. So 12 plus 7, which is 19. And the other one, which is 5 plus x. So this is what the trick is that you're now dealing with a monomial, which is fine. You'll be fine. You've known how to do this. It's the same thing. So what we now have to do is determine our proportion. Well, they're on the same side, so you should know that x has to be proportional to 5 plus x, and it has to equal 12 over 19. Just a proportion. So we cross multiply once again. We're going to get 19 times x equal to 12 times parentheses 5 plus x. So just make sure to distribute. So we're distributing. So we're going to be left with 19x equal to 12 times 5, which is 60. Yep, sorry. 60 plus 12x. So I just distributed the 12 to both sides. Our next step is to get x's to one side. So I'm going to subtract 12x from both sides. We're going to get 7x equal to 60. And now I just have to plug in my calculator, 60 divided by 7. And so what that's going to equal is 8.57 centimeters. Okay. So So it's a lot, it's a little more work, but it is just cross multiplication and proportions. We've been doing that since 7.1, and then solving out to x. You just have to set them up, seeing what is being sawn here. Great use of English. All right, we've got one more, and that is number 6. And we are done for this week. Okay, so once again, it is very similar to 4. We're seeing that they share an angle. They also share corresponding angles because these two lines are parallel to each other with a transversal going through them. So this once again is SAS or AA and or. So we need to determine what x is. 9 and 20 are good to go. They are proportional to each other, so we know 9 over 20. I'm actually going to give more space so you can see it. 9 over 20. And it has to equal, well, 11, because that's over there. But we have no idea how long this one is. And that is where we're going to see that it is 11 plus x. Again, just making sure you understand that. So I'm going to just rewrite this as x plus 11. Doesn't matter either way since it's addition, it's commutative. Now this is just proportions. We cross multiply, we're going to get 9 times x plus 11 equal to 20 times 11. We're going to distribute the 9. We're going to get 9x plus 99 equal to 220. I now need to get my x by itself, so I'm going to subtract 99, where 9x is going to equal 121. I'm going to divide by 9, and x is going to equal 13.44 centimeters. Okay. All right. That is the end of this lesson. I know it was kind of a long one, but we're almost there. We're getting through. All right. If you have any questions, make sure to email me or come to Zoom meetings.